Welcome to Computer Simulation. First works on computer simulation of induction coils were made in the 1960s. Due to a limited access to computers, their low memory, speed, and poor programming methods, the computer simulation did not receive significant industrial application until the 1980s. Now, computer simulation has become a practical tool for everyday use in the induction industry. It allows the user to design optimal systems, improve equipment performance, dramatically reduce development time and costs, and to better understand the process dynamics, etc. Though there are still difficulties in accurate simulation of nonlinear and different mutually coupled tasks, computer simulation is effectively used for design of induction heating coils and problem solution. This chapter is based mainly on experience of the author, his colleagues, and his collaborators in development and use of computer simulation programs in different areas of induction heating. When to use Flux 3D simulation. When good information and results cannot be achieved using 2D with reasonable approximations. In order to evaluate 3D effects for some systems where 2D is used with some assumptions, such as lead area in cylindrical coils, crossover parts of single short coils, etc. To understand some uncertain effects from experiments. And, of course, for simulation of complex 3D systems, such as gear hardening, welding, some brazing systems, etc. Flux 3D software features may be electromagnetic, thermal, or coupled. Material database with non-linear properties is available. Usage considerations. More complicated and less user-friendly than Flux 2D. Requires powerful computers for reasonable calculation times. Time and knowledge consuming for problem formulation, geometry description, and calculation process setup. Gear heating simulation using Flux 3D. Eddy current density distribution in a quarter of a gear tooth. Frequency 50 kHz. Concentrator Ferrotron 559H. Gear modulus is 5 mm. One can see that maximum current density is in root area near the tooth end. Pipe to brazing simulation with Flux 3D. Color map of optimal power density distribution between the components of aluminum heat exchanger. See more details in the Case Stories chapter. Accuracy of 2D and 3D computer simulation depends upon accuracy of system geometry description, accuracy of description of material properties and processing parameters such as quenching intensity. Problem formulation. There are several options how to describe the electromagnetic field in 3D systems. Number, distribution, and type of elements of simulation mesh. Algorithms used in the program and software quality. Position 1 is the most important for 2D simulation when the user needs to neglect 3D effects of real induction systems, such as lead area in a cylindrical coil, spirality of multi-turn coils, etc. Calculation errors may be reduced to negligible values by means of proper selection of mesh and calculation process parameters. Accuracy of simulation also depends on experience and knowledge of the user, especially in 3D simulation cases. Conclusions. At present time, personal computers are powerful enough for simulation of most induction heating problems. 1D and 2D simulation are well established in induction industry. 3D simulation is an emerging technology. Computer simulation is a powerful tool for induction process and equipment design, optimal design of induction coils, research and development, development of databases of processes, projects, and coil designs, troubleshooting, advertisements and business presentations, training, education, and self-education. New advances in computers, software, and databases of material properties will lead to wider and more effective use of computer simulation in induction heating. This concludes this section. Thank you for viewing computer simulation for induction processes and coil design.